Okay, to people joining this live stream, we are looking at some Wolfram language design. This is our incremental language design meeting series, and we have a variety of topics. First, we're talking about threaded, which is a very lovely thing coming in the next version. And this is documentation. Boy, those look a little bit old school mainframey. Why are they boxes like that? Is that because they can be any number of, who can speak to what this is? Is Rob here?
Those are the levels, right? The levels in the
Well,
array.
no, the box in the first one, and that's why we use different colors. And in the first one, the boxes are, places for elements or, possibly subarrays.
Why are they three-dimensional? Because they can represent something with their additional dimensions lower down? Or
they could potentially. They don't have to be three-dimensional. We just thought that looked a lot nicer than just, I originally had something written out in two-dimensional and it wasn't, the virtual elements, which are the grade ones, were not as obvious.
I see.
Okay.
But of course it could be higher dimensional, but this is from the blue gray one is really two-dimensional. The gray green ones are multi-dimensional, but right, each one of those boxes in green or gray is a level, right? It's
right.
Dimensionality.
Right. So the blue represents elements, and the green we chose a different color after discussion.
But the problem is that you've got the same iconography of boxes, and that's not right. In this case here, these represent levels, right?
Right.
So you shouldn't have boxes here because these are just abstract levels. They're not. You need different iconography. Do we have somebody from design here?
We do not. We did this with Tim.
Okay. Yeah. Well, is Tim here?
No, I can ask for Tim.
Yeah, okay. You could get Tim. That would be useful actually.
Okay. All right. This isn't right. You can't have the same iconography for this case and this case. You see why I'm saying that?
Sure. We chose different colors, but yes, you're probably right. The iconography should be a bit different. Maybe they could be, ellipses for the dimensions or something like that. Yeah.
I don't know, but it should be different. Okay, but let's look at functionality here. Yeah, okay. Maybe you could have one more basic example. I do think that showing this as a basic example that you can have arithmetic on the threaded. What's the case in terms of the threaded? I see. So you can have scalar arithmetic on threaded.
Yes. Yes.
This is a very nice construct, by the way.
Yeah, I think people are going to find it super useful.
Yeah. And the implementation is efficient, right?
Well, not as efficient as it can be yet. It's still Mark is still working through a whole bunch of parallelization stuff so that we really get it right. So that probably won't be in this version, but it will be coming. And okay. Once that's done, it'll be super efficient.
Right, but we're talking about sort of a factor of 2, right? Not a factor of 1.
Well, it depends. It depends on the sizes you use. It can be as little as 1.5, a factor of 1.5, but it can be as big as a factor of, 5 or more, depending on, it depends on how things get unpacked.
Okay. Ethan on our live stream is pointing out that threaded should work with image channel data. Isn't that exactly what it's doing here?
Yeah, that's the point of that example.
Okay. And it's also pointing out, add a target device for doing things on GPUs. Is that plausible? That's, I think, has to await compiler stuff, doesn't it?
That has to await that. Yes. Ultimately, yes. And the point is you'll be able to use threaded I mean, I've written the code so threaded works within the compiler as well. Not at full efficiency yet until Mark gets his magic done, but yes, so you can use threaded within the compiler, and then when it can compile to GPUs, that should just work.
This is great. This is a great piece of functionality. Let me just look at the documentation here. Will B automatically be threaded? Fix.
Right. Okay. Sorry, I missed that.
Will automatically be threaded is the lowest level of an array when used in a listable operation such as plus. Are you sure there isn't a way to write this out with a B1, B2, B3?
No, because you need at least two levels in one.
Yeah,
of
it's a
them.
mess. Okay, all right.
I hate to say it, Stephen, but that's actually what we originally had, and you said you didn't like it. So
Okay, fine. Yeah, okay. Yeah. Fine. Okay. Did we get Tim or not? We can, or just look. What we need, what is the right way to show a level? And I think there may be iconography that we have in the trees project for showing levels. We might investigate that. Do you get what I'm saying?
Okay. Well, yeah. So Jose and I will work with Tim to try and get the iconography right. Then we'll merge the branch and make this live. Okay.
Merge the branch. You can go ahead and merge the branch.
Okay.
Go ahead and merge the branch. This is close enough. I mean, there's just details of graphics.
So the thing here is that we have to represent two different things. The fact that we are threading through a bunch of levels and the one which we are using to align those two sets.
I agree. I understand. Yeah. Align two sets. What do you mean? Align.
So you see that there are some green levels and one of them is kind of a darker green. The darker green is the alignment level. The other ones follow because we always have to thread through all levels of B.
I need to be working with some designer if I'm going to have opinions about this. This is what we need, an idea here, but definitely lose the three-dimensionality on this thing here. I would say how to represent a level. I mean, in a sense, this is like a tree. This is going down a tree, is it not? If we were to draw the tensor as a tree, these would be
not a tree, right? It doesn't have a single root, right? I mean, each one of these things represents a slot. If you're going to use a tensor, right? Tensor slot, an index, right? Each one of these is an index.
But these are indices like T, A, blank, B, blank, and they're different. So these are. This is
right. So if you have a tensor T, A, B, C, right, then the top rectangle is A, the middle rectangle is B, and the lowest rectangle is C.
Is that right? Or is it a tensor A, B, C, D, where it could be that one of them is B and one of them is D? In other words, I don't think it's all the indices of the tensor that you're representing here, is it? Or am I confused?
Well, I guess the first and last ones are...
right, so this is you're picking out a tensor index in the middle of the list of indices. You're using one of them as the anchor index, and then the other one here is the index BLAV that has gone down. I don't quite understand this. Why isn't that ALAV? Wait a minute. That's ALAV. Yeah.
So let's think of threaded. Of map thread. In map thread, one threads through n levels, which is the third argument. So that's what we are doing always here. We are always threading through as many levels as B has.
Yes, I get it.
Yeah. And those are the green levels. So that's why on the right, they're all threaded. On the left, only the green levels are threaded.
Yeah, I understand. I think you should label this whole stack as being A, this whole stack as being B. That's one thing that would be helpful, I think.
Right, you're right. I guess the point is, right, that the dark green one is the first index of of B. The lighter green one is the last index of B. And then, you know, when you switch over to the A, right, those are the corresponding indices in A, wherever they may be.
Okay, so I've got a suggestion. First of all, these are contiguous levels. This ... is not contiguous. Here they are contiguous. I would draw them out as just unlabeled green boxes. See what I'm saying? Lose the light green, dark green, and just there's a labeled green box and then a bunch of green boxes and then another, you know, because if you've got like thin green boxes here, nobody's going to count the green boxes and think it always has to be that number of green boxes. But the point is that that ... means something different from that ... there. Because all the contiguous B levels are used. Right?
Yes.
Well,
Yes.
I mean, they're still contiguous. It's just
But,
they're
yeah,
unspecified, right?
All the ... are contiguous.
That one is not contiguous.
Yes, it is.
Yes, it is. You're starting from 1 until you get to n minus 1.
No, no. I know, but you're dropping those things there. You're not using them, right? Whereas here, every single level from 1 to I is used here.
Right. So I think what you're saying is that it's not clear in this diagram whether the ... are gray or green.
Yes, that's right. That's
Maybe
right.
if you had arrows pointing from the A-dim Aleph to B-dim 1, and likewise for that lighter green to the B-dim I, you make that correspondence clear.
Yeah, that's fine. I mean, look, what you've got to do is these ones like connect here.
That's what I
Right.
mean, the arrows
Yeah.
right between those.
But I wouldn't put ... I would just have, because it's a contiguous thing. It's like you're taking this whole tensor, this whole range of tensor indices. Okay, I'm not going to do this without graphic design. Okay, so I think my suggestion is you have a bunch of green boxes here, unlabeled in the middle. You label the end ones. You have ... there, and you know that's how you do it. Okay, and I agree with you that having something that indicates that these are the combined things, like have the plus sign sit in here. You get what I'm saying?
Yeah, that would be good.
Mm-hmm.
Okay.
Okay, we can take that to 10.
Okay, fine.
Yeah.
I'm not wild about the three-dimensionality here unless it means something. Okay, if it really means something, if it means that these are being listably added, then fine. If it doesn't mean that, then I would not have three-dimensionality. I'm making sense. Does it mean that or does it not mean that?
It could mean that this could be generalized to 3 dimensions, but we would have to be very careful about how things work.
Yeah.
So it's very difficult to infer from this diagram what's going to happen in 3 dimensions.
Drop the three-dimensionality.
Right. So then
Find
we need
another-
some different iconography for dimensions to make it clear.
No,
which-
it'll be okay. If you drop the three-dimensionality here, you drop yes, you're going to need different iconography, but it's going to be much more straightforward to get it.
Mhm.
I'm not going to do this without design. So if we don't
Okay.
have design, let's not do this right now. Okay, splice.
So we added
Okay.
a second argument to splice that specifies the head. Basically, just
Wonderful. Okay, do we see an example here? Yes, the head splicing.
Yes, and it uses patterns in the second argument, as you suggested.
Okay, maybe we should show an example of that, even in basic examples, because that seems pretty useful to me. Like putting a blank there will just splice into any head.
Right. There are examples in scope, I think, but not in basic.
I would put a blank there and just say this splices into any
Yeah,
head.
the last one of scope is one of those.
No, it's not a pure blank. It's not a.
I
I'm
see.
saying a pure blank.
I see.
Pure blank that
Yeah.
will splice into anything.
Mhm.
It's just like sequence. With a pure blank, it's just like sequence, isn't it?
Well,
Yes,
blank,
there is a note.
but blank, right? Blank of F is basically a pure blank.
It's
right?
not. It's an F. It's a head-dressed thing.
Oh, okay. I see.
I mean, that's a
Yes.
perfectly good example. I like that example. It's just there's a more basic example, which is just a pure blank.
I think there is a note saying explicitly that
Okay,
blank is
fine.
sequence.
And you should also show it in properties and relations. Oh, look at that, you do. Well, except you should show it with an actual blank.
It's the next one.
Brilliant. Okay, good. Okay, looking good. All right, delete adjacent duplicates.
So this was a function we talked about a while ago. Danny has implemented it. We're finishing up the documentation here, but I had a couple of questions about if we wanted some related functionality and just to make sure that.
What about a
everything's
same
equal.
test? Does it have a same test? It does have a test.
Yeah. Yeah. Second argument.
And we want a second argument as opposed to a same test option.
We have both things in different functions. For example, delete duplicates has a test, or tally.
Like this. Okay.
Yes.
Yeah.
Yes.
Mhm.
Okay. What was the question?
Well, so delete duplicates also has a by version, and I wasn't sure if we wanted to generalize this to have a by version. I mean, that,
It seems a little bit on the niche side.
It does. It really does.
I would
Yeah.
wait until the users clamor for it
Yes.
before going that step.
Right.
Right. Okay. And then there's also a predicate version of delete duplicates, or I guess duplicate free. I'm guessing adjacent duplicate free is going to be a little niche also, but just trying to
Absolutely.
round out.
Don't. I wouldn't put that in. I mean, maybe it's a WFR for now.
Yeah, I was going to say that could be
Okay.
good that far.
All right.
Okay.
That's easy enough then. So I started looking at positions, largest, smallest, and the by versions. Danny's also taking some look here.
Yeah,
but-
I started working on it today for real.
Okay.
So, I think I can just do it.
Yeah. So I have a question about whether we want to have a second argument in terms of n largest values, because we start to run into a question of how we handle multiplicity. You know, if I say I want the three largest values, do I want effectively what take
Yeah.
largest three
I
would give?
understand. The question is that list of length equal to that number, or are you asking if there
No.
are? No, I understand. Or are you asking for the things, if you were to rank order all the things of those ranks, so to speak, return?
Yes, I would say the latter because that's the non-trivial interpretation. The other can be done with take largest.
Well,
Yeah,
I would say that
okay.
the question is whether we want to generalize take largest to do that too, which would be very useful.
To do what?
I mean, of the many things that now take largest can report, I think reporting multiplicity would be great.
Wait a second. Take largest does report multiplicity, as in it just returns things of that
Right.
with
No,
the
no,
multi-
I mean the arrow notation. The arrow notation in which we can use now value, index.
I
So
think you'd be trying to tack on to take largest something that's really a bit out of its realm, Jose.
Okay, so hold on. Property can be the element, the index,
Yes.
the multiplicity. No, but the point is that take largest is simply returning a subset of list. Okay, so if there is a multiplicity of things that are all largests, those things will be returned with their multiplicity, as opposed to processing, whether it's index or not. I mean, if we say take largest, and then we say something like 1, 1, 3, 4, 5, 5, okay, and we say take largest, comma 3, we'll get that, right? And
That's why I'm
presumably-
arguing that the rank interpretation for position largest actually gives something new.
Okay, hold on. So let me understand this. So this is, okay, that's the index. Those are the indices. But I don't think, right, but I don't see what multiplicity would do.
So my point here is that it's typically very difficult to know how many there are of the largest. unless you call tally and rank and tally everything. So I think what we are missing is a function that can tally just the largest, the few largest.
I understand. Because if this were that number 3 is just a guess, and the question is, I don't know how long that the largests are.
Correct.
Why isn't okay? So what we have right now is we have commonest, for example, which gives us what you're asking for. No, what commonest will just okay. One thing you could ask for is give me a list of. Okay, here's a function that would be useful potentially, maybe. Am I confused here?
I think perhaps what I'm asking for is tally with give me just the 3 largest.
No, you know what you need? What you need is the second argument. Look, what you need is this. Take largest. Hold on.
It's a little bit like the nearest, where you have a radius and a count.
Yes, that's right. But what about something like this? Take largest automatic, which would then give us the instead of giving take largest a particular number,
I actually think that the nearest interface is the closest we're going to get to something that we could retrofit.
But what do you think of this idea?
I don't know what automatic would mean.
Oh, what it means is,
oh, give me all the ones that are tied for the largest.
Yes.
How about up to? So up to 1 means
but
then the largest.
But you have an ambiguity in what the n argument means if you're going to keep that n argument.
Well, n is like a ordinal.
Oh, I see. So up to 2 would mean give me all of the things that are in the top 2 ranks.
2 unique, like 2 unique without their multiplicities.
Yeah, that's what I mean by ranks. Yeah, the top largest unique values.
Okay, but there's a problem with that, which is what if I say take largest? Look, if I do this, and maybe I'm wrong in how this works, but if I say take largest here,
I think we already have an up to meaning.
Well, I know we do because here's what it is. If I say up to 8,
yeah,
right?
Yep.
So we've already used that. So let's take a look at the nearest thing.
So it would be radius comma count, I believe. And so you might have a radius of 0, but that only works to get your very largest.
Radius comma count.
So it'd be 0 comma infinity. Give me as many as possible that are exactly equal to the largest.
Yeah, I understand. It's obscure.
Well, not only that, but it doesn't generalize if you want more than one rank, more than the top rank.
Right. So what we want, really what it is instead of the count, we want the ranks. Instead of that second argument being a count of the number of elements, we want it to give the R largest ranks. Give everybody in the R largest ranks. Right?
Yeah.
So either it's one case is count of elements, and the other one is count of ranks.
As a general comment, up to there should be a second alternative to up to that takes into cardinals and not ordinals, because it's always confusing what it means. Usually I think of the up to as up to infinity means all, but if you use it in a span, in a part, for example, it has this meaning.
What does it mean there?
Well, it doesn't work usually. If it's like a first argument, it's confusing.
So if you say take,
if you use part, part with a span.
Oh, I see. Okay.
This in some way reminds me of the differentiation in bin specs in histogram, where we have bin
Yes.
widths, and we use a list notation to differentiate there. It's
I
not
see.
my favorite.
No,
but
it's not
it
my
is a
favorite either. But I
process.
mean, so the possibility would be a rank here. That
There-
could mean
Mhm.
the top rank.
Yeah, my other thought was some sort of headdress, but it's maybe going to be specific to say rank 1, like with an explicit head.
Well, I wonder
Yeah.
whether there's other places where that's useful.
Yeah, I mean, the only existing functions we have that have rank as a prefix are rank max and rank min.
Which are related to this.
Yeah, they are related to it.
What do they do? Do they do exactly this? No, they do.
No. So I think take largest is, and Danny can correct me if I'm wrong, but I think it's based on some of the internals of rank max, where that's giving the
That's correct.
And largest
value.
element. So
Yeah, there's code shared.
okay, the nth largest element, as opposed to the elements which are the nth largest elements.
right.
Right. This is the nth element of take largest.
Again, cardinal versus ordinal. It would be nice to have a distinguish those.
Let me understand that statement. Let me understand that. So the function that is the missing function here is give me the things. Okay, so what we are missing is give me all the nth ranked. Give me all the elements in the nth size rank. Right? That's the function we don't have. Is that correct?
Right.
That is what
But-
we will be doing is we'll be taking this and to rank them, how do we put these, how do we tally these by rank? We would say, what will we do? We say sort. How do we tally these by rank? I mean, we could say counts, and then we could say sort of counts.
So for this, tally and then reverse sort by last is very useful.
Yeah. Okay, which is equivalent to this.
It's just coincidentally ordered in tally there. But
Indeed.
Right.
Right. It's not even ordered. I mean,
oh yeah.
Every time I use tally, I always use reverse sort by.
yeah.
I think
Well,
we did well in take largest to sort things. Here it's missing.
yes. Well, I mean, I also do that for counts. I often sort counts, or sometimes I key sort counts. But actually, the fact that you can do both of them is very useful, both key sort and sort, if you understand what I'm saying.
Yep.
Okay, let me understand Nick's comment about cardinals versus ordinals. Can we unpack that for a second? So what's an example? Okay, let me just understand. What is a quintessential example for us? An ordinal case is something like part specification. Is that what you mean?
Yeah, usually. Yeah. Ordinal is when you specify a span for part specification. Those as an integer, it's an ordinal.
I see what you're saying. So you're saying an ordinal is like a okay. So the difference would be give me certain elements of a list as opposed to give me the 5 largest elements of the list. Give me, you know, in other words, okay, so the claim would be take of a list is ordinally getting me like 2 elements of the list.
Right.
Whereas, are you claiming that take largest is somehow cardinally giving me? Is that right? Well, commonest is certainly am I confused here? Can you explain? Anybody understand? I'm slightly confused.
So my view of this is that indices or position specs are ordinals and lengths are cardinals.
I see.
So for example, when we discussed, do you remember when we discussed infinite lists and we were trying to join 2 infinite lists? So the question is, what's the position of the first element of the second infinite list?
Yes.
And so
yeah,
that's
okay.
an
So
ordinal.
you're saying, okay, so you're basically claiming that length of infinite list you claim is, aleph 0 or
Right.
whatever.
Right. That's a cardinal.
Right. Whereas you're claiming that the index, let's see, what will be the how will we even get that? The position of the last element.
Last range.
So for example, I think it's clearer if we have 2 infinite lists. The first one is A1, A2, A3, A4, A infinity, and the second one is B1, B2, B3. If we join them, what's the position of B1? The answer should be omega plus 1.
Yeah, right.
Omega plus 1.
Yes. Okay, so you're saying, I don't know how I exactly do this, but let's say, well, I mean, here, by the way, when we have an infinite list, presumably we will have a generator here, a generator function. So let's say our generator function is like that. And you're saying join of this to infinite list B ampersand, and then we say first position of B.
No, I would say position of B1.
Well, I did B ampersand, so I did
I see. Okay, yeah.
So that would be omega
plus 1.
Right. Do we actually understand I mean, we've had a couple of implementations of infinite lists. Do we actually understand how this will work in terms of transfinite numbers and so on? Is that something within range, or is that not within range? I kind of think this is something we should be, as we think about these evaluation graphs and so on, we are going to have to deal with this. But okay, let's come back to this.
So just to say one thing, the fundamental problem was that we need a non-commutative plus. And so we cannot use plus because 1 plus omega is omega, but omega plus 1 is omega plus 1.
What about up values on the ordinals?
I don't think we can. Plus will fire immediately and do something.
Not if there's an up value. Not if omega is ordinal number. Blah blah blah. What if there's an up value on ordinal number?
But do up values overwrite the orderless attribute of plus?
Oh,
right.
I see. That's a Bugosaurus. That's an interesting problem. Well, the real issue, I think, is that, Cantor normal form or whatever we're going to use to represent these numbers, that's kind of like digits. This is a solvable problem. I don't see the solution immediately, but explain to me how we think about, okay, here's a naive question. The transfinite numbers Okay, this is a super naive question. I should know the answer to this. Anybody know the relationship between the Peano axioms and transfinite numbers? Do the transfinite numbers, I mean, they are not integers in the sense of satisfying the Peano axioms, presumably. Or am I confused about that?
I don't know. I don't know the answer.
Okay, we need to. We should have a discussion about transfinite numbers and infinite lists. I think we can solve this now. And I think we need to solve it because I think we need this concept. We need to generalize the idea of transfinite numbers to transfinite graphs and so on, because that's what we're going to need for these evaluation graphs. Anyway, okay, that's an irrelevant point. Okay, let's come back to the points here. Okay, so what we need is something where we are asking for. So Nick is commenting that up to, I mean, I agree, but I think that's a symptom, not the cause. That up to in one case is a cardinal designator and the other case an ordinal designator in take largest. But the question is, how do we get everything of the first rank versus everything, I mean, okay, ranked max is the nth largest.
Now, does ranked max, it doesn't have doesn't it allow to take a range?
Doesn't look like it.
Hmm.
Looks like it's just because after all, I mean, that's the question, is whether you could have the nth through mth largest elements.
Right. That may be where the place to attack this, not through take largest, but through ranked max, since it has rank in the name.
Well, but you're suggesting that a rank max of list comma n comma multiplicity could give, I mean, so that's one possibility, is that we could say, though I don't like it because it's going to be change the type of output, but anyway, ranked max of list comma n comma multiplicity, and that if multiplicity is all, I mean, I don't like it because it's going to give a list.
Yeah, I wasn't even thinking in terms of giving a multiplicity, but I guess we would need to, because right now it only returns an individual value.
Right, but what you're saying is, what we want is okay, so first we were talking about position largest, right? So the question is this a rank or is this simply a take spec? And Danny is arguing that it should be a rank because that's more useful. The concern is how different that is from take largest.
Right. Yeah.
Just to throw another monkey wrench in the thing, Raj and I are working on a set of commands called partial ordering and partial sort, which for a one-dimensional list does a sort, but it lists the elements by their rank.
Lists the elements by their rank. Say that again. What is
for
that?
One-dimensional for a one-dimensional list?
What is it called? It's called partial sort.
Partial sort, right?
Okay, and what does it do again?
It generalizes to multiple dimensions where it finds sort of, it finds ranks of elements in, the plane or higher dimensions that are not dominated by other points. But the one-dimensional case is very similar to what you're talking about here. So like partial sort of say 1, 2, 3, 1 would give the list list of list 1, 1, comma 2, comma list, comma 2, comma 3. Okay. So it gives a sublist for each rank.
Hold on. Why isn't that just split of sort?
Because there's the generalization to 2 and higher dimensions,
Okay.
which relate to those. Remember those vector inequalities, the vector less equal, the vector greater equal. And so, yeah. So this may be a little unrelated, but the 1D case does sort of overlap.
I don't like
So-
the name. I don't like the name at all. I don't think. I need to be sold on the name.
Yeah.
Okay. Because the whole concept of partial orderings is something that we need to do a lot more with, post sets, partial orderings, and so on. I don't
Right.
think we want to use up this name for this concept.
Well, no, that this is just the 1D yeah, the whole the concept we have of partial sort and partial ordering is related to the whole post set thing.
Okay, but it's a very special case of post sets, isn't it?
No,
Anyway,
yeah. So fine. So I just thought I'd
Yeah, okay.
mention that.
Okay. All right. Okay.
That-
So let's come back to the question of, and we have to wrap in just a minute here, unfortunately for right now. And I know that's a shame because Danny is in the middle of trying to implement this.
It's all right.
I don't have an immediate thought here. I think this is a well exposed issue. I think we are going to need, again, so one solution, which I don't like very much, is the braced second argument to take largest.
Mhm. Yeah, it seems like the consensus is it is useful to be able to generate the ranked result. It is just a question of what the best way to do that is. So maybe we'll do some brainstorming. And for now, we can work on the single argument version of position largest and the buy functions and
Yeah.
think about this as
Right.
Remind me, what does ranked max do when there's ties?
So ranked max, there's an example on the page right there at the very bottom. Ranked max, or on the agenda, if there's 2 instances of the largest value, then it will give the largest value for the second
I see.
result.
Okay.
So
Thanks.
it's not giving back rank. The second argument isn't the rank, it is the nth
I
largest.
see. It's a raw number, so to speak.
Yeah.
Okay, got it.
Well, so just what you're saying. So the numbers are put in their rank order, and then the bucket, whatever number it is that is in the second bucket, is what is returned. No, that's not right.
No. There, it's tantamount to order comma -2 in that example,
Mhm.
or the element that is at that position.
Mhm.
Okay.
This requires more thought, guys.
Yeah. I was wondering if there was a potential shortcut here, but there isn't.
Okay.
Okay. To be continued. See you guys soon.